Boing, boing, bounce, bounce. Jump, jump, pounce, pounce. Spin around, touch the ground. Tap your knees, then make these sounds. Boo, boo, hee, hee, boo, boo, hee, hee. Ba, ba, beep, beep. Ba, ba, beep, beep. Come and count 1, 2, 3, then play you and me.
The Earth is flat. The Earth is flat. Around the edge is Antarctica, which is an ice rim that resides along so you can't fall off. You have to go over what would be Antarctica. Now the rest of it is in the middle. So you got the flat Earth right there. The sun is over this plate that is the Earth. And it rotates or revolves around a center axis, and that way you get day and night on there. But meanwhile, oh, by the way, I didn't tell you this. The sun is only 4,000 miles away on this plate. 4,000 miles. The Earth is flat. The Earth is flat. The world is flat. Around the edge is Antarctica, which is an ice rim that resides along so you can't fall off. You have to go over what would be Antarctica. So you got the flat Earth right there. The sun is over this plate that is the Earth. And it rotates or revolves around a center axis. And that way you get day and night on there. But meanwhile, oh, by the way, I didn't tell you this. The sun is only 4,000 miles away on this plate. 4,000 miles.
I don't care what you say.
People that believe the world is flat.
Get the freaking hair out of my face.
You freaking suck.
Go freaking away. I'm freaking...
Dude, look at you.
The Earth is flat. The Earth is flat.
I hate Christmas very much now. I hate Christmas. I'm not making cookies to help decorating the house or decorating the trees. And I'm not dressing up for Christmas Eve or Christmas just to go somewhere. And this is for all the kids in the world that think Santa's real. He's not. Your parents have been lying to you all this time. It's awful. My mother broke my Christmas spirit. My mother broke my Christmas spirit. So now I'm not doing anything, and she wishes she could change it. She should have told me a while. Now you know Santa's not real. This is a song, one of Santa's songs. He doesn't see you when you're sleeping. He doesn't know when you're awake. He doesn't know if you've been bad or good. So don't be good for goodness sake. Thank you. This is a message to all the kids in the world. Bye.
There was once a time when our little planet seemed immense, when it was the only world we could explore. Its true size was first worked out in a simple and ingenious way by a man who lived here in Egypt in the 3rd century BC. In Alexandria at that time, there lived a man named Eratosthenes. One of his envious contemporaries called him Beta, the second letter of the Greek alphabet, because he said Eratosthenes was second best in the world in everything. But it seems clear that in many fields, Eratosthenes was alpha. He was an astronomer, historian, geographer, philosopher, poet, theater critic, and mathematician. He was also the chief librarian of the great Library of Alexandria. And one day, while reading a papyrus book in the library, he came upon a curious account. Far to the south, he read, at the frontier outpost of Syene, something notable could be seen on the longest day of the year. On June 21st, the shadows of a temple column or a vertical stick would grow shorter as noon approached. And as the hours crept towards midday, the sun's rays would slither down the sides of a deep well, which on other days would remain in shadow. And then, precisely at noon, columns would cast no shadows, and the sun would shine directly down into the water of the well. At that moment, the sun was exactly overhead. It was an observation that someone else might easily have ignored. Sticks, shadows, reflections in wells, the position of the sun, simple, everyday matters of what possible importance might they be. But Eratosthenes was a scientist, and his contemplation of these homely matters changed the world, in a way, made the world. Because Eratosthenes had the presence of mind to experiment, to actually ask whether, back here, near Alexandria, a stick cast a shadow near noon on June the 21st. And it turns out, sticks do. An overly skeptical person might have said that the report from Syene was in error, but it's an absolutely straightforward observation. Why would anyone lie on such a trivial matter? Eratosthenes asked himself how it could be that at the same moment, a stick in Syene would cast no shadow, and a stick in Alexandria, 800 kilometers to the north, would cast a very definite shadow. Here's a map of ancient Egypt. I've inserted two sticks, or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved.
Dogs and Englishmen go out in the midday sun. The smallest Malay rabbit deplores this foolish habit. In Hong Kong, they strike a gong and fire off a noonday gun to reprimand each inmate who's in late. In the mangrove swamps by the python rumps, there is peace from 12 to 2. Even caribous lie around and snooze, for there's nothing else to do. In Bengal, to move at all is seldom, if ever, done. But mad dogs and Englishmen go out in the midday, 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 out in the midday sun.
Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away. That its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows of different lengths. For the observed difference in the shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment. With those tools, he correctly deduced the circumference of the Earth to high precision, with an error of only a few percent. That's pretty good figuring for 2,200 years ago.
How would you set about to measure the Earth with the mathematical knowledge and tools you already possess? A Greek named Eratosthenes did it 240 years before Christ. He was head of the great library of Alexandria in Egypt, a city built by the Greeks. He, like others, suspected that the world was round. After all, the sun and the moon were round. He had also noticed that the sun's rays fell in parallel lines. Greeks before him had divided the circle into degrees and had measured angles. With this information and a logical mind, he measured the Earth. Here is how. While visiting the city of Syene one midsummer's day, Eratosthenes noticed that the reflection of the sun could be seen in the bottom of a deep well. The sun was overhead, and the rays pointed to the center of the Earth. He remembered this, and on the next midsummer's day in Alexandria, he measured the shadow cast by an obelisk. Sunbeams travel in parallel lines, so the difference in angle had to result from the curvature of the Earth. If the angle was 1/50th of a circle, then the distance around the world must be 50 times the distance from Alexandria to Syene. With these simple tools, Eratosthenes made this almost exact measurement of the world more than 1,700 years before Magellan sailed around it. He was a friend of Archimedes. He was a mathematician and a poet, invented the sieve for finding prime numbers, was the first geographer, and corrected the calendar to the one we use today.